Hi everyone, this is Presley. My paper topic is Behavior Based Anomaly Detection of Cyber Physical Attacks on Robotic Vehicles. This paper was written by George Lucas, Richard J. Anthony. So they are from University of Greenwich. Whenever we talk about cyber physical systems, they are integrated with networking and also they have lot of physical processing. So in this days, they are facing a significant security challenges. These security challenges are particularly critical for autonomous vehicles, where cyber attacks can have severe physical impacts like accidents or even loss of control. So this paper's primary goal is to facilitate the automatic detection of cyber attacks on a robotic vehicle. In order to achieve this, they came up with a detection mechanism that performs real-time monitoring of data from various sources of the vehicle, such as sensors, networks, and processing units. During the training phase, the system learns the whole process of the data from various sensors and networks uh, on a non-attack mode. Once it is trained, it continuously monitors the vehicle's operation using a binary classification model to detect whether the vehicle is under attack or not. Whenever we look the past history, they mainly focused on the traditional approaches in terms of the cyber physical security. They mainly focused on the passive attacks, particularly on ensuring the confidentiality of communication between vehicles and the smart infrastructures. So in 2009, University of Washington conducted an experiment on vehicle cybersecurity. This laid a groundwork for understanding the vulnerabilities in vehicle systems. However, as the technology has evolved, the attacks are increased. Today, autonomous vehicles are frequently targeted by active cyber attacks. These attacks can directly compromise the integrity and availability of the vehicle's systems, potentially leading to a significant physical consequences. Uh, a major limitation of traditional detection is the reliance of prior knowledge of attacks. These systems are typically trained to recognize specific attack signature based on past instance, while uh, in the whenever there is an unknown attacks or new attacks come up, this definitely fails because these are trained on past knowledge of attacks. So so, in order to achieve this, they have came up with a few detection requirements, like in order to have some uh, cyber security for the autonomous vehicle, they must have some detection requirements like real-time detection. Cyber attacks can happen very quickly. If there is any delay in the detection, this can result into a significant physical damages or even operational disrupts. Therefore, the system definitely needs to respond in a real time very quickly. And secondly, the system has to operate without any human interruption. In most of the autonomous vehicles are often expected to operate independently, making it essential for the detection mechanism to function reliable without constant human oversight. At last, uh, the system must be capable to detect unknown attacks. Unlike traditional approaches that we just studied, they rely on predefined signatures or known attacks. So this paper's main aim is to detect the unknown attacks. So in order to achieve these goals, they came up with behavior-based approach rather than the knowledge-based approach, because instead of relying on the historical attack data, these systems continuously monitors both cyber features such as communications and computation, and physical features such as actuations and sensors. During the initial learning process, this system established a normal behavior profiles for the vehicles by observing its operation in a non-attack mode. So these profiles acts as a expected range for various data points. Whenever there is some changes in the data points, this detects that there is an attack. Further, in order to further develop this mechanism, they came up with weights. These weights prioritize anomalies that are less common, thereby improving the system's ability to identify and respond to unknown attacks. This weighted approach ensures that the detection mechanism remains sensitive to significant deviations while minimizing false positive. In order to do this experiment, they came up with a test bed system design, as we can see in the figure. So, so this test bed vehicle is highly modular robotic vehicle. It can mimic the complexities and the challenges faced by the real world autonomous vehicles. So in this design, they used different sensors like compass, ultrasonic sensors, and pitch roll sensors. This compass is used to say the orientation of the vehicle, and it is important for navigation. And also these ultrasonic sensors is used for collision detection and avoidance, because as it is an uneven environment, and also is it is an unknown environment, so there has to be an collision detection in order to avoid any collisions. And also these pitch and roll sensors are used to uh, tell the vehicle stability and also the tiltness of the vehicle. They have used the CAN bus. It's a controlled area network bus facility for intercommunicational communication between the vehicles of the various components. And also for the external communication purpose, they use Zigbee in order to transmit the data to a remote workstation. It provides a low power, but uh, it has the robust communication link. So, and for the live transmitting, they use the Wi-Fi. So these are the uh, uh, components that they have used. This is the architecture, internal communication architecture of the robot vehicle test bed. So they have used gateways. So they have used the gateways connected by a central CAN bus. This setup facilitates efficient data exchange and control signal propagation among processing nodes and sensors. These are responsible for real-time data processing and analysis. The architecture includes several processing nodes that can handle data from different sensors and actuators and generate indicators for monitoring the cyber and physical attacks on the vehicle. To validate the effectiveness of this detection system, they have conducted an experiment in a carefully controlled environment that represents the realistic challenges. So, in this picture, we can see a a corridor which is in the Greenwich University with an irregular surface. This setting provides the necessary sophisticated elements in order to simulate the real world conditions. So, during the training phase, the vehicle was operated in a non attack state to gather the data for establishing a normal behavior profile. The vehicle navigated through the corridor multiple times, collecting the data on various sensor readings such as compass bearings, ultrasonic sensors, and pitch roll sensors. This data was used to define the normal operation ranges for each sensor, which would later serve as the baseline for the anomaly detection. In the testing phase, the vehicle was uh, the vehicle used the same way or the same corridor. The goal is to evaluate the system's ability to detect the anomalies and potential cyber physical attacks based on deviations from the established normal behavioral profile. The irregular surface of the corridor uh, ensures that the vehicle sensors were continuously challenged, providing a robust test for vehicles detection systems. Throughout the experiment, the data was collected and analyzed to identify any deviations from the normal profile. So, uh, this is the signature for normal behavioral profile, which is central to detect anomalies in the vehicle's behavior. In the initial phase, they focused on creating a normal behavioral profile for the vehicle. This profile is formed using 11 distinct characters that captures various aspects of the vehicle's operation. During the learning phase, the system collects data while the vehicle is operating in a non-attack state, as we discussed earlier. This data is then used to establish normal value ranges for each of these characters. Once the learning phase is completed, the system is continuously monitors the vehicle's real-time data and compare it to the learned signatures. These signatures serves as a reference for what constitutes normal behavior. So in this image, we can see that there is a table. This table is categorized the various signature characteristics like raw, exponential smoothing, deviation, spike areas. So, and also there is a work methodology workflow. It illustrates the process followed for anomaly detection, where the L1 is the learning phase. The system learns the signature characteristics of each data source. L2 is the weights generation phase, where weights are generated for each characteristics based on the learning phase data. And V is the validation phase. Data source inputs are validated against the learned and weighted characteristics to detect anomalies. And using this, the final output is the result of anomaly detection, whether it is where there is an attack or not. Using this, we can find out whether the robot is under attack or not. So the second one is anomaly weighted and indicator confidence. In order to further refine the detection mechanism, they came up with this methodology. This has an additional learning phase that allows to assign weights to different data sources based on their likelihood of appearing anomalies. During this phase, the system analyzes the normal operational data to understand typical variabilities in each data sources. By doing it, it can differentiate between the attack anomalies and also the normal ones. So, in this figure, we can see it demonstrates how anomalies are identified and summarized according to different data sources. So, the run one and run two. These matrices displays binary indicators of zeros and ones, where each cell represents whether an anomaly was detected for a specific data source or not. So the run file is the summary. These matrix gathers the data from multiple runs to provide a comprehensive view of anomalies across all the data sources. In order to calculate the weights, we use the formula W of Cij. where the formula is 1 minus C of j, where C of j is the mean frequency of anomalies for each characteristics across all the runs. So here is the detection of workflow. So in this, like there are few five steps. So in the first, the real-time data is collected from various data sources, and then this data is compared to the normal profile that done in the training phase, and also a binary matrix is created to indicate the presence of anomalies. The binary weights is multiplied by the learned weights to produce a weight of anomaly matrix that we can see in the learned weights. So from there, the weighted anomalies are summed to produce an overall anomaly index, which indicates the likelihood of an attack. So yeah, this is the uh, where these matrices shows the different experimental scenarios, including compass manipulation, rogue node attack, packet injection attack, broken wheels. So these all are the experiments that the uh, that this paper has done, that we are going to look in the next slides. So to validate the detection mechanism, they conducted series of experiment scenarios, each designed to test the system's response to different types of cyber physical attacks. One of the scenarios involved is a replay packet injection, where previous collected data is replayed at different insights. This type of attack can disrupt the vehicle's communication and control systems, causing it to behave unpredictably. Where we can see in this picture, uh, there is a graph that um, shows the different behavior. So it is indicated in the red box. There is a significant disruption in the sensor reading. Initially, the bearing remains stable around 180 degrees, but as the packet injection begins around the 40 seconds time, uh, the readings become fluctuated, and there was large fluctuations across the attack and became normal. So this type of attack is called replay packet injection. And the second one is like rogue node, where in this attack, the this attack will be introduced into the internal network, replaying packets at an amplified rate. This scenario stimulates a DOS attack similar to DOS attack, which can overwhelm the vehicle's network and impair its functionalities. So we can see the second figure, figure 10. Before the attack, the packets rate was very low and stable. Once the rogue node attack begins, around the 30 time, there is a sharp increase in the packet rate, reaching up to 150 packets, and this evaluates rates persist during the attack phasing, indicating the rogue node's activity as it amplifies the packet transmission within the network, causing the significant rise in the network's traffic. And also, they have done different like compass manipulation. So in this attack, they used a compass in order to um, uh, alter the sensor reading and disrupt the vehicle's navigation. So we can see in the figure, like there was an high rise in the at the 45 time limit, there was a uh, various fluctuations and also increased in the bearing sensor data. And also the last experiment they have conducted is mechanical failure like broken wheel. This scenario demonstrates the system ability to identify not only the cyber attacks but also it when there is a physical malfunction, it should detect the physical malfunction as well. To evaluate the performance of these detected systems, they introduced or they used receiver operated characteristic curves and AUC in order to measure the accuracy. These metrics helps to understand the system's accuracy in distinguish between normal and attack state. When we see the packet injection attack, this system achieved a high detection rate as indicated by the AUC score. The deviation caused by the attacks were significant enough to trigger the anomaly detection mechanism consistently. So they achieved a nice high detection rate. When we see the rogue node, the application of weighted anomalies improved the detection rate subsequently. These systems were able to identify the attack more accurately by reducing the false negative. The compass manipulation, even though there were a disturbance caused by these magnets, uh, s- they achieved a high detection accuracy with the system correctly identifying the abnormal sensor readings. Overall, the performance evaluation demonstrated by this detection system enhances the system ability to detect various attacks. So these are the results that are came up by doing the performance evaluation. So they got the high detection rates for known attacks, and also uh, for the unknown attacks, the performance is improved so they can detect both cyber attacks as well as physical attacks caused like broken wheels, etc. In the conclusion, they have developed an anomaly detection methodology that effectively identifies cyber physical attacks on autonomous vehicles. Our approach leverages real-time monitoring, behavioral-based detection, and weighted anomaly analysis to ensure robust security against known and unknown threats. Looking ahead, uh, in the future, they will focus on expanding the variety of attack scenarios and exploring more complex operational environments where they aim to refine the detection mechanism further, ensuring it remains effective under challenging conditions. Thank you so much.